is we are hosting a live webinar on May 9th, International Astronomy Day. And it's going to start off with a pre-recorded talk with David St. Jacques, as well as then we're going to tune in live for a Q&A at the planetarium in Montreal, where you'll have a chance to submit questions. Then we're going to go into seeing live views of the moon and some pre-recorded and just celebrate Canada and RASC and the moon and astronomy and have a nice big party. And we're also, so with that, if you have any feelings about the new moon mission and you want to share it with us in a video that you would like to be featured, check out rasc.ca/shooting-moon-webinar. And we're looking for content to include to represent RASC members there, because this is a party for you to feature how great everyone is in the astronomy community in Canada. So that's my little spiel. And so I'm going to let Chris get started with a very fun episode today.
Thank you. Yeah, so what we're going to do, we're mainly going to focus on diving into Leo today. And I like to do these deep dives. Samantha and I were talking before the show about these deep dives. What's great about learning a lot of extra detail about a constellation is that, you know, it's good to have fun facts at your fingertips. If you're doing public outreach or you're at a star party or just with friends and family, you can point to that star and say, hey, did you know that it's this distance away, or that it's spinning super fast, or it has a hot Jupiter orbiting it, things like that. So those, spoiler alert, those are some of the things that I'll be mentioning today. And we'll go into some of the really cool things that you need telescopes for and some things that you'll do imaging for. So, but before we do that, I want to share my screen and just highlight some breaking news, and then we'll do our quick Messier Minutes section, and then we'll get into Leo. So let me just open up my Stellarium here. So in case you haven't heard, this week is the best week to see Mercury for us in Canada, mid-northern latitudes, for all of 2022 in the evening sky. And this is the sky tonight at 9 p.m. looking west-northwest. And if you have a chance, if your skies are clear to the west, make an effort to get out there, and you can spot Mercury. Should have no trouble finding it. It should be nice and bright. It's already brighter than magnitude 0, it's just a bit under magnitude 0. It's still not finished. It's still getting better. So every day that goes on this week, it's going to get high, a little higher and a little higher, and higher. It'll finally reach its greatest elongation, I think, on the weekend or so. And while it's doing that, it's actually paying a visit to the Pleiades cluster. So let me just zoom in a little bit. There is this comet, Pan-STARRS, in the neighborhood as well, but it's twilight, so I don't think we're going to get a good look at the comet. It's just setting as it gets dark. But yeah, if you want to take a look at Mercury buzzing past the Pleiades, that's going to happen April 30th, May 1st, kind of 3 or 4 days worth of close. Now, because the Pleiades is so big, it's tough to fit them both in a telescope view, you know, even with a really low power eyepiece. It can be a challenge to fit them all together, but you can definitely fit Mercury and part of the Pleiades cluster in sight at the same time. So try to get out there. You know, if you get yourself set up around 9, you should be able to spot Mercury then or soon after that. And any clear night this week, head on out and take a look. So that's my sort of little heads up for something cool to look at in the way of bucket list information. Also, there's the next new moon, which happens on Sunday, Saturday, Sunday, is a partial solar eclipse, which won't be visible around here. It'll be visible in sort of the coast of Antarctica and Tierra del Fuego part of the world. But you can always watch a live stream of that. So a couple little things to whet your appetite for what's newsy. So what I'm going to do now is I'm going to bring up the Messier list objects here, and we'll go through our Messier minutes. So we're marching along quite nicely doing our spring targets. We've pretty much done the lion's share of the spring targets, if you pardon the expression. And this week we're going to just clean up a few leftovers that we didn't get to when we talked about the Messier objects that were in the Virgo cluster region here between Virgo and Leo. And first up on the list I've got noted here is Messier 49. So you can see that 2 Messier objects, 49 and 61, are located due south of the main clump. So this is where your Markarian's chain galaxies are and things like that. So 49, just bring this into the center here and zoom in on it a little bit. So again, I'm simulating a view using a 6-inch Dobsonian telescope, reflector telescope, and a nice common low power eyepiece, 26 millimeter Plössl eyepiece. If you've got, a shorter focal length, you'll be able to zoom in and make it bigger. But, this combination gives you a nice, healthy 1.5 degree field of view. So it makes finding the objects a little bit easier to do that. So M49, as you can see, it's magnitude 8.3. It's south of the main cluster. The way I like to recommend people find it is that it's actually on the line connecting Minaleva, which is this star. No, where are we here? There, Minaleva and Denebula. So there's our tail of Leo. And if you connect a vector between these two, you'll see that M49 is right on that line. And it's about 40% of the way between Minaleva and Denebula. So a little bit closer to the Virgo star than the Leo star. This one is visible in good binoculars. It's bright enough for good binoculars and smaller telescopes. And if you've got bigger apertures, then you can start looking for, it'll grow bigger in size. It's an elliptical, so you're not going to get a lot of extra details with a bigger aperture telescope, but you can do that. You can also look for other galaxy nearby. So we've got the NGC 4535 spiral, face-on spiral galaxy nicknamed the Lost Galaxy of Copeland in the same neighborhood. So if I were to say, click on a star here and put it into my my Dobsonian reflector, you can see that we can pick up in the same field of view these other two galaxies in the neighborhood of M49. So we've got the Hairy Eyebrow Galaxy and the Lost Galaxy of Copeland. And then if you've got a really dark sky and a big telescope, you can look for all kinds of other galaxies in the neighborhood. So M61, you can find, my recommendation is to use that Minaleva star and New Virginis. So if you pick the upraised arm of Virgo and draw a line down to that Minaleva star, it's kind of halfway along that line joining those two stars. So that will get you in the neighborhood. M61 is a small but very pretty face-on spiral galaxy. It's not really binoculars target, but it's visible in smaller telescopes where you'll get the central brighter sections. Larger instrument, you'll start maybe teasing out some details in the spiral arms set. Let's see. Yeah, and this one's known for growing with averted vision. So that's why its nickname is the swelling spiral galaxy. So if you look straight at it, you'll notice the core more. And if you look to the side with averted vision, then you'll notice the arms more. So that's a neat one. And just to give you the comparison, that's how it would look in that Dobsonian reflector telescope. Okay, next up, we're going to jump up into Coma, another outlier, and go into Messier 64. Coma, the Messier 64 is not near really any signposts or easy things to use, but one of the tricks you can use is to try to see if you can see the three main stars of Coma Berenices here. And if you draw a vector across the hypotenuse, then you're going to be close if you sort of stick to the 40% of the distance from the bottom to the top and find that. If you're using a low power eyepiece, you should have no trouble putting it into the view if you do that. This is a called the Black Eye Galaxy. It's kind of an obliquely tilted spiral galaxy. It's nicknamed the Black Eye. It comes from dark dust that's in the center. I'll just zoom in here. This is a kind of an enhanced Hubble view. If I put on the Deep Sky Survey image, you'll get a more realistic, RASC sort of view. This one's about 24 million light years away. So if you have a bigger aperture, you might be able to start teasing out some of the details in the Black Eye, which is a dark dust lane kind of in the core. All right, and then Next up is M104. So M104. Where's our M104 here?
Down lower.
That's right. That's right. It's a low one. There we go.
I just made the finder charts. That's the only reason I know.
So M104 is down there, even farther away from the Virgo cluster. It's down there between Crater and Virgo and Corvus. So M104 is a great one, though, even though it's kind of low for Canadians, or lower for Canadians. This is the Sombrero galaxy with the dark dust lane running through the middle. So this is a great one. Quite bright, magnitude 8. So that's because of its high surface brightness. So all of the starlight's being sort of gathered into a narrow zone, a lozenge-shaped zone, giving it an overall bigger brightness. That'll let you see it in big binoculars, smaller telescopes. And then if you have more aperture, then you could start seeing if you could pick out the dark dust lane bisecting the two sort of sections of the galaxy. To find that one, I make an isosceles triangle with Spica and Porrima on the bottom side of Virgo here. So Spica, you will have no trouble identifying. So just sort of build yourself a triangle using those, and you should be able to pick it up. Again, it's nice and bright, so it shouldn't have any trouble seeing it. That one's about 29 million light years away. This one's actually receding from us at a very high velocity, and an anomalously high velocity. And there's actually a neat asterism right up here that you can pick out in the eyepiece. So there's a neat asterism of stars. It kind of looks like a garden hose sprayer nozzle with the hose coming up and the gun and the trigger. So see if you can pick that one up. And last up is M83, which is even lower. And M83 is going to be better later in the evening, so towards midnight. And this one is the Southern Pinwheel Galaxy. And this one, it can be a little tricky to find if you can't see the star Menkent. Menkent's a great tool for finding it, because if you can spot Menkent, then you can draw a vector up from that up to the two fainter stars at the tip of Hydra. And it's about halfway between those two. But this one is a another gorgeous face-on spiral galaxy. Let me just put it in the colossal eyepiece again. Transits around midnight, as I said. You should be able to get it in binoculars, although you're looking through quite a bit of air mass for us in Canada. If you're folks that live further south would have more of an advantage. It'll be higher in the sky for them. So small telescopes will pick the center, but then a larger aperture telescope will let you start noticing the spiral arms. And you'll notice that they're not symmetrical. There's some asymmetry to this. So see if you can tease out some of the structure when you're looking for it, some darker patches. Some of these dark dust lanes that are kind of internal can add some texture, some modeling to the overall effect. So that one's about 15 million light years away. So those are our Messiers for now. In 2 weeks, we've got a moon-filled night, so we'll focus on some of the brighter objects in the Messier catalog for late spring, early summer, but that's the Messiers for now.
We do a couple of questions about Mercury. I'm sorry I missed these earlier. One is, what makes Mercury so remarkable these next couple weeks?
Oh, what the reason I'm highlighting it is because it's so easily visible for a change. So normally, quite often when Mercury swings east of the sun, it's in the evening sky. But often when it does that, its orbit is quite a bit tilted with respect to the plane of the solar system. I'm not sure if it reports here the inclination of the orbit. I can't remember off the top of my head, but it puts Mercury quite a bit to the north or quite a bit to the south of the ecliptic quite often. And so a lot of times, the ecliptic will be more slanted, plus Mercury will be south of it or below it, and it just doesn't climb very high in the sky. But for us at this time of the year, it's nice and wide east of the sun. It's on the north side of a fairly upright ecliptic, so it just makes it more extra visible for us. So that's why I'm highlighting it for you. A lot of, Mercury only sticks around for, sometimes it's a week and a half, sometimes it's 2 or 3 weeks, but it's kind of a bucket list thing that people like to chase after. So that's my reasoning.
And just to remind us, what time can you start to see Mercury?
Yeah, so at 9 o'clock, you've got a nice balance between the darkening sky and this planet. If you want to use binoculars, you can search for it earlier. It'll be a little higher, but please make sure the sun is completely set before you point anything like binoculars or a telescope to the west. So, even as late, you say as early as 8:30, you might be able to start looking for it. At 8:30, it'll be about 1.3 outstretched fists above the horizon. And if you can't see it then, just give yourself a few minutes. With every passing minute, it gets easier.
And one more question before we move on.
Yeah, by the time you get to 9:30, you're kind of getting really tough. So 9 o'clock is your prime target. Sorry, go ahead.
Good early evening target. Someone's quickly one more before we move on. Our planet's fairly consistent in sky year by year. Well, we've been teaching this in NOVA. I'll let Chris elaborate, but one of the reasons you don't really have it on your planetarium or sky charts is because they change so often when they're up and when they're visible. So you don't have them on those printed charts. Chris, can you elaborate a little bit more? Or?
Yeah, I mean, they're always in motion. So, you can't rely on seeing them at the same time every year because they're on a completely different schedule than we are. We return to the same skies, the same stars on the same dates every year, year after year after year, but their years are all different amounts. So Mercury swings around the sun every 88 days. So it toggles between the morning and evening sky on a pattern or on a schedule that's just not consistent with our calendar. So it always varies. For example, right now, Jupiter, Saturn, Mars, and Venus, they're all in the pre-dawn sky. That's just the luck of it. We don't have any other. When Mercury disappears here in a couple of weeks, we're back to no planets in the evening sky until Saturn arrives in late June.
Thank you. And one more thing, as Judy said, if you're looking for when they're going to be visible, things such as that, the Observer's Handbook, look for the most current edition, and it will give you all the charts of the movement of motion of the planets and when you can see the best and things like that.
Or you can tune into Sky
and we'll tell you. And Sky News too.
Yeah.
Lots of resources. Okay.